In this tutorial I will show you how you can create a moving platform in three-dimensional space for a jump and run game like you can see here. Okay, how did I create this? You can download these two files from the video description, and this is all you need for this example. So we create an empty and we will call this pass, and we will create a 3D object called cube. And we add some empties to this pass. We will drag and drop the waypoint pass to the pass, the platform to the cube, drop the pass to the pass, and set an animation curve for the animation between these platforms, for example a 1. And there you go. You move these points to the desired position, hit play, and everything is working. So this was very fast. We will make this a little bit slower and go into the detail and try to program these two scripts by hand. Let's start by adding two scripts to our project. So we are going to create script and call this platform, and we do it again. Create script waypoint path. In our scene we are adding an empty game object. We will call this pass, and we're creating a cube. This will be our platform, so we will make it not that high, and you will see this is a pretty decent platform. We will call this platform. Okay, we will add the waypoint path to the pass and the platform to the platform, and we will add some empty game objects here. This is point 1 and this is point 2. So the pass will be at 0, 0, 0. The first point also at 0, 0, 0, and the second point a little bit higher. So we can't see our pass, nothing is happening when we hit the play button, because now we are starting to programming our logic, and we will start with a waypoint pass. So we'll start Visual Studio and open our waypoint pass. At first we will create a protected, or maybe a public list of vector3. These are our waypoints, and we will hide them in the inspector because they should be generated automatically. To fill these, we will add a new public void refresh method, and here we will check if waypoints isn't set right now. We will create a new list. So now we have an empty list of waypoints. If we already have waypoints, we will clear them right here, and after that we go through every child in get component and children transform. So, and as you know, every game object has a transform, so we will go through every game object in the children, and sometimes Unity interprets the component itself as a children, so we should skip that and just saying this dot transform equals child, and if this condition is true, then we will continue. And of course we can skip this, and I think that's it. Okay. It's a reference comparison. But this should be fine. Type to object. No. It's okay. Okay. We will add the waypoint child transform. No. It's not a transform we were getting right here. Okay, child is an object. It looks a little bit strange to me because I would expect the child is a transform. Okay. Child transform. Get components and children. No, there was an S missing. So now everything is a little bit better. Now we can add the position. Okay, when should we refresh? We should refresh on start, of course. When the game starts, we will get a fresh child list. There's an on transform children changed, so it makes sense to refresh here. And maybe we should add on draw gizmos just for the editor. And here we will draw something. So at first we will refresh to have a complete child list. And then we will set the gizmos color to color black. And we will go through every waypoint in the list. And as long as I is smaller than waypoint length, so I will iterate through all the elements in this waypoint list. And gizmos draw sphere directly at the position of the waypoint we are currently looking at with a value of 0.1. This is a radius, and there we go. This is our waypoint path. Let's have a look. Yeah, we can clearly see this point. It's pretty big. We can make it a little bit smaller, and maybe we can connect these. So if I equals 0, then gizmos draw line from waypoints I to waypoints count -1, so from the first one to the last one, and otherwise just draw it from I to the predecessor. And hopefully we will see a line. Okay. Maybe make this slightly bigger so that we can see this. Oh, perfect. So now we can see our waypoints. We can add some points, and as soon as we add the point, you see there is immediately a new line, a new dot, and we can move them around, and the platform will move along the lines as soon as we implement the platform script. So the waypoint path is ready now. Let's go to the platform script. So the first thing the platform need is a waypoint path. And here we go. We can drag and drop the path to the platform script. Now the platform knows which path to follow. There are a few things left. So for example, a speed. Plug public float speed. We will set this to 1 initially. As soon as we drop the script on any game object, it will be initialized by 1. We will use an animation curve. This is animation and a protected int current index or current VP index. Okay, maybe you don't know what this is all for, but I will explain it now. So as soon as we start, we set the current index to 0 because this is the point we are at right now, or the platform is at right now. We should force it with platform position equals path dot waypoints 0. And as soon as we start, this should already work. The platform should move to the first point, right? And now it has to move. So we have to know a few things. So we have to know the previous target, and this is obviously the current VP index -1. But this won't work if the current VP index is 0, so we have to make a distinction. If it's 0, then it's the last element in the list, and the last element we will get with count -1, and we'll have the last element. So this is the previous target. We will calculate the current target just by retrieving the waypoint at the current VP index. Then we need a vector from the current position to the target. So we say, okay, the current position minus transform dot position is the way we have to go. And to go will be the amount of distance we will travel in this specific frame. So we will take the magnitude of 2 target, multiply this by the speed, multiply this by time delta time, and let's stay it as it is. So, and now we have to switch as soon as we reach the target. So when do we reach the target? We reach the target if the 2 target magnitude is smaller than any small amount, like maybe like this one. Or if the distance we are traveling right now in this frame is larger than the distance to the target. So this magnitude sorry, this to target normalized. So now we can say, okay, if this to go magnitude is bigger than the target magnitude, and then we will have it. So let me clarify this for you. So we have this waypoint, for example, this waypoint, and this waypoint. So, and we have a current target, maybe this is here, and we have a previous target, this is here. So, and we're maybe here right now. So, what we will calculate is this one, and this is to target. Okay, and now we will have to calculate how far we have to travel. So what we will take is a 2 target vector and normalize it. Maybe this is 1, so normalized. Then we multiply it by the time and the speed, and we will get something like this. So, and if this is far, or this is greater than the complete vector, we know, okay, we have to be extremely in the range of the current target. Maybe it will be this long, and then we know, okay, it's longer than the distance to the current target, or we are already very near at the current target, then we have to switch the index. So how do we do that? Pretty simple. We just say index equals index plus 1, but we have to take care, if we are at the last element, it has to switch to 0. We will use a trick here. Just takes a count as a modulo for this complete calculation, and it will automatically set the VP index to 0. Okay. Good. It's very good to set the go to target to target, because this is bigger than to target. So, and to target is exactly the difference between the current target and transform position, and we will modify the position here. Transform position plus equals to go, and there we go. This will set the platform directly to the current target. The current target will be switched here, and everything can continue over and over again. Okay, let's have a look at our platform. So it's already moving up to this point because the index is out of range. In 22 here. Of course, brackets are missing, but this is not the only thing that's wrong here, because as you can see, the platform is very fast and doesn't stop at the end. It's just moving. There's no smooth move of the platform. It's too harsh. So we will add this animation curve to this product. Just say, okay, animation curve, evaluate, animation, and now we have to calculate a value. So the value is between 0 and 1, and we want to have a 0 value when we are close to the source, and we want to have a 1 value as soon as we are close to the target. So, and how do we do this? We have to divide the distance, so the current or the travel distance divided by the distance. So, and the to target magnitude is the distance from the current target to the end, and we will subtract this term from 1, so we have 1 at the end and 0 from the beginning. So how to calculate the distance is very easy. We just say, okay, vector 3 distance between the previous target and the current target. Just have a look at it a couple of times. You will understand it as soon as you leave something out or have a look at this in the debugger. It will be more clear. But now we will see a different behavior. Nothing happens. This is the case because we have to set a curve. For example, something like that. We want to move slowly at the start and the beginning, and fast in the middle of the lane. And now we are seeing the complete thing stops or nearly stops at these points. And if you're creating a jump and run game, it will be much easier for the player to jump on these platforms because he has some time to consider how he jumps. And if this whole speed is too low, then you can add some speed to it and it will be faster. So that's it. I hope you like the tutorial. Please leave a like, subscribe, and watch all my other tutorials and leave some feedback to it.